Good afternoon, and thank you very much for joining us today. My name is Vera. I work for Seascape, Belgium, which is one of the 20 partners of the Blue-Cloud project. And on behalf of the Blue-Cloud partnership, it is my honor to welcome you to this pitching and award event, which marks the last closing phase of the Blue-Cloud Hackathon, and which will determine the winners of this hacking event. Over the past 54 very intensive hours, nearly 150 participants from 73 different countries, grouped in 31 teams, guided by 27 mentors, have been working on addressing 7 ocean challenges using resources available in Blue-Cloud. I want to, first of all, thank all the teams that have joined the hackathon. Big thank you for putting your time, your skills, and effort into contributing ideas to respond to these ocean challenges. The challenges addressed by the hackathon may represent a small fraction of the massive mission that we have ahead of us to truly decode the ocean. But as someone once said, the journey of 1,000 miles begins with one step. So once again, thank you very much for putting your best foot forward for the ocean. And a big shout out to all participants, but I would say very especially to all those teams that have managed to make it all the way to the end of the last hackathon milestones, for your endurance and for your determination. Today, 7 judges are going to be deciding what teams are the winners of the Blue-Cloud Hackathon. All of you, as well as participants to this webinar, are going to get a chance to vote for your favorite team. Today, as you know, this webinar is an open event, which means that everyone is welcome. In the past days, there have been many exchanges amongst the hackathon participants with mentors, consultations with the judges, all happening behind the hackathon doors. But today's live event, for today, we really wanted to open our doors and give everyone an opportunity to learn more about the great ideas that the teams that have joined the hackathon have been evolving over the last few days. So this reflects in the agenda that we have set up for this live event and that I am about to share with you. Shortly, I'm going to be giving the floor to my colleague Michele Erba from Kreativdistrikt, who has done an amazing job helping us to roll out this hackathon. And Michele is going to be briefly sharing some interesting numbers with you regarding participation to the hackathon. You can go one slide back, Michele, as we go over the agenda. Right after that, we're going to welcome the Blue-Cloud Hackathon judges, who have done an extraordinary effort in the last hours to complete a first evaluation of the finalist teams. And with them, we're going to start a video pitching session, displaying one by one the video pitch of each team that has made it to this final. So I'm now talking to our hackathon participants. If you see your video pitch played, get ready, because that means that you're about to engage in a short exchange of questions with the judges live. So basically, as I said, we'll be playing each video one by one. After each video, we will be inviting each respective team to a short Q&A session. And after we've shown you 10 videos, and that's how many finalist teams have been shortlisted, the judges will retreat to deliberate for about 30 minutes to decide on the winners of the first, second, and third prize of the hackathon. So that means that we will be breaking for about 30 minutes before we come back to announce the winners. But during those 30 minutes, while our judges are away, this webinar will continue to run, as we're going to be using that time to open a voting session so that you too can vote for your favorite team. And the winner of this popular vote will receive the Blue-Cloud Blue Skies Award. So basically, and as we have explained before, as it's been explained in the terms and conditions of the hackathon, today we will be giving away 4 awards: the first prize, the second prize, the third prize, and the Blue Skies Award. Our judges will decide the winners of the first, second, and third prize. And all of you who are attending this live event today will have the first and last word in deciding the winner of the Blue Skies Award. So I hope that's a good introductory overview. I say, let's get things moving, Michele. And before we welcome our judges, could you please share an overview of what has been happening on board the hackathon over the last 3 days?
Absolutely, Julia. Thank you very much. All right, guys, so it's time to run some numbers here. The numbers that you see here is the number of teams that made it until the end. So basically, we had 24 teams distributed in 4 topics. As you can see, the main participation was in challenge number 3. But we had also some teams in the topic 1. Then we had topics 2 with 4 teams and topics 4 with 3 teams. In total, guys, we were 111 participants. As you can see here, we had a lot of participants from Europe, of course, but we had some friends also from North America, from Central America, and South America. Some people from Asia, some people from Africa, and this is great. I mean, guys, a lot of diversity, and see that global consideration of this event. It's fantastic. Thank you very much for participating. A big thank you. I mean, you saw me on the platform in these days, and I also saw the work that you've done with the mentors. The mentors have been great. We had 27 of them, and as you guys communicated with them, it was fantastic, really. It was fantastic. And I'm sure that you guys also had a lot of cups of coffee. I'm sure of that. I mean, I had a lot. We have, as Julia mentioned, we had 7 judges. You get the chance to meet them later. Some of you, I know that some of you smash some keywords because, I mean, you get angry sometimes when things cannot done. In the chat, in the tornado, we had around 8K messages, meaning that it was really, really thriving there. A lot of people communicating, a lot of people interacting, which was really great. And also we had a Spotify release that we're going to talk about later. Then here, as you can see, we have some numbers about the Blue-Cloud. As you can see, the Blue-Cloud Open Sense ecosystem has been put to a test here in these days. We have witnessed an intensive use of Blue-Cloud resources. Here you can see the session on our studio. You can see the session on Jupyter Hub. You can see the data sets, accesses from workspace. So here, these numbers are fantastic again. And thank you very much for these guys. It's all up to you. Now it's time to talk about the teams that are participating in this challenge. I'm going to start, of course, with topic 1, with challenge 1A, which was mapping hotspots of plankton diversity. We had 4 teams participating in this challenge. We had people from Switzerland, from France. I mentioned our friends from South America, so people from Ecuador, and then a team from Belgium. These are the name of the mentors also here on the right that you can see that help these people develop their ideas. Then we can continue with the challenge 1B, which was about tapping on environmental and molecular data. And here we had 3 teams participating, people from Poland, Norway, Greece. Again, this is the country of the team leader. But we have, as I mentioned before, a lot of diversity in each team. So there were people working from Europe with a team member in Central America, in Asia, and so on. So this, again, was great to see. Here we have the 2 teams participating in the challenge 2A, which was about assessing the environmental risk of aquaculture cages, people from Germany and UK. And then we can skip to 2B, which was about maximizing food return, minimizing risks. So here we had a couple of teams, again, Germany and Belgium, and you can see the mentor that helped this team. We can continue right on with the challenge 3A, which were about making prediction about environmental condition of a marine area. We had a lot of participation here, so 6 teams that made it until the end of this hackathon. But as Julia mentioned before, we had a lot of more people that registered for this hackathon at the beginning. And here we see that we have people from Hungary, Germany, Croatia, Romania, Ireland, Netherlands. So everybody from Europe here. Then we can move on with the challenge 3B, anticipating the effects of climate change on marine ecosystems. And here we had 3 teams participating, most of them from Italy, 1 from Germany. And then here we have the last one, which is the wildcard. And in the wildcard, we had 3 teams, people from Croatia, from Czech Republic, from Ireland. And the challenge was about how might we use Blue-Cloud to advance knowledge of the ocean. So this was basically the topic of this challenge. All right, Julia, back to you.
Yes, thank you very much, Michele. Well, I'm glad to see that we didn't smash too many keywords. I guess that's encouraging, but it's even more encouraging to know that we have 10 teams that have made it all the way to the final stage of the hackathon. I'm really looking forward to hear more about the ideas presented by these teams. But before that happens, I would like to first give a very, very warm welcome to the judges of the Blue-Cloud Hackathon. And I'm going to invite you, Silvia, Dave, Othman, Elisa, Massimiliano, Barbara, Dimitri, to please turn on your cameras. So I guess I would say if this was an in-person event, I would invite a warm round of applause to welcome you. As it is, unfortunately, we cannot hear our audience clap, so no point really. But I want to say how grateful we are for the effort that you, the judges, have put in reviewing the deliverables submitted by teams. We are really honored to have an extraordinary jury with members with a very diverse background and also a very busy agenda. And we've asked you to leave everything, your lives aside, basically for a good number of hours. So again, on behalf of the Blue-Cloud Consortium, thank you for your work and thank you for joining us today and welcome. So without further ado, Michele, I'm going to please announce the first video pitch that we're going to be seeing as we start the video pitching session. And remember, teams, that if you see your video played, your spokesperson has to be ready to answer some questions from the judges. So Michele, over to you, and let's see the first video.
Thank you very much, Julia. So the first video is from the team, the Particle Trackers, and you can see what they produced during the hackathon now.
Are you an aquaculture manager looking for a pollution-free location for your next farm? Or a decision maker assessing if aquaculture farms can pollute marine protected areas? Or are you simply looking for clean and safe fish to eat? Then See Clearly is a tool that can answer all of your questions. The Particle Trackers used the Blue-Cloud to develop simulations and a web-based visualization to track pollutants in the ocean. You simply open the web page, click on the location of an aquaculture farm from the Blue-Cloud database, and trajectories of harmful pollutants appear, which have traveled to or from this farm. So how did we produce these simulations? In a Jupyter notebook on the Blue-Cloud, we combined an open access Lagrangian framework called ocean parcels with ocean currents from CMEMS, and released virtual particles of one pollutant, microplastic, from one origin, the coasts or the aquaculture farms. With an extra €25,000, we will integrate other Blue-Cloud data, including all pollutants and aquaculture farms, marine protected areas, and even winds and waves to simulate storms. With our probability analysis, we will generate a public, fair, compliant contamination risk map of the Mediterranean to share with stakeholders and educate the general public. Everyone has the same goal when it comes to aquaculture farming. Producers, consumers, and decision makers want to ensure safe, clean marine-based foods. Let See Clearly provide you the pollutant tracking you need.
Well, thank you very much, Dolphin and Victor. I hope that you're ready. Members of the Blue-Cloud Hackathon jury, the floor is all yours for questions.
May I start then?
Please.
Yes. So Very nice. I want to congratulate the team. It's a really very nice work. Very well also explained in your video. I have a technical question, especially on the development that you want to do with further if you win the prize. You are talking also, so you are releasing some particles, inert particles in your dynamic model in a way, in your trace model. Which additional pollutant, because when you are saying additional pollutant, you are not explaining which one you would like to target, and some are possible to use in models like you are proposing, and some not, like the dissolved one. And the second part of the question is also how do you integrate, you are proposing this tool for the aquaculture sector, and this definitely is really very important and a very hot topic. But how you can integrate, so plastic is not enough for the aquaculture sector to know, and the pollutants to know where to put the cages. How you can integrate this model, this tool, with the other tools that are telling you instead the suitability of some location based instead of other environmental parameters.
So Elisa, thank you very much for your two questions. I'll start by answering the first one. So firstly, I think the main aim of this is to really look at what pollutants are available on the Blue-Cloud, and the ones that, as you said, can be transported by the currents, which is really what we're using. So the Lagrangian particle tracking framework is really focused on these passive particles. So yeah, when it comes to looking at, for example, the particles that are released from the aquaculture cages and seeing if they can end up in marine protected areas, it would be seeing if there are toxins, for example, that we can actually use as these pollutants that we would release from the aquaculture cages. Yeah, when it comes to your second question, do you mind just summarizing in one sentence the question again, so that I can try to focus my answer?
You are proposing this tool for the aquaculture sector, where to put the cages or how to, yes. But this is not to know where the particles and some particulate pollutants are, is not enough for the aquaculture sector to decide where to put the cages. Would be nice to have the integration between your tools and other tools that are deciding the suitability of the location. Have you thought about this?
Yeah, sure. I've got to say, in 2 days, we haven't had any chance to look at, which other tools are out there already. And we are not aquaculture specialists, right? So we're oceanographers. So that would be a really interesting collaboration to see how we can include that. One of the things that we do intend to do is to include other data that, again, is available in the Blue-Cloud, and to simulate different situations. So for example, if there's, for example, a storm or other environmental data that we can, include into the model. But yeah, the actual app that we have that's now available online in beta version, it's a very flexible tool. So I'm sure that including other software into it would be possible.
Thank you.
Thank you very much, Elisa. Thank you very much, Dolphin. I'm not sure, we might have another question from our judges.
I have a question, Julia.
Please go ahead, Massimiliano. Thank you.
Yes, more a bit technical. So we have been looking at your notebook. I have to say it was one of the most complete and organized. It is a fairly good proof of concept. Now, suppose that you are requested to evolve this proof of concept and convert it to a more user-friendly app. Assuming that Blue-Cloud provides hosting, or you have hosting, what technologies would you use? What would you do? And will your team have all the skills that are required to create this user-friendly app?
Yeah, so I'm actually going to refer the answer to Victor, who was very heavily involved in the coding.
Yeah, so in terms of what we can do going forward, the expertise we have in our group, we have a lot of the modeling side. So all of the Lagrangian particle tracking we can definitely do on our own. And as for the visualization aspects, we have some experience with, again, those same particle trackers, but here we especially have Olmo, who is the one that created the entire visualization tool. One of the things we want to do is to create an interface that the idea is that you can click on on the map, and this will tell you information about this site. It will require some work to get the integration from, okay, what's this position that you click on? What's the long lat? How do we convert that to model output? Where this depends a bit on the type of analysis. The particle tracking, the forward and backwards tracking, this is something that we definitely have the expertise already. You just need to set it up on Blue-Cloud that it can run. The Bayesian analysis, this is much easier in a sense, because this, you just need to run one larger model simulation and upload this Bayesian data file. And then if you have that, it's a very simple matter of just being able to sample what site you're at and providing the answer. So I think, yeah, between all of us, we definitely have the technical knowledge to grow this forward. And where we don't, we are able to hopefully collaborate with the Blue-Cloud team to make it work on this platform.
Okay, thank you.
So thank you very much, Dolphin and Victor, for your elaborate responses. I think we're ready to move to the next team, right, Michele?
Exactly. The next team is Ocean Warning.
Well, that's a great pitch. So the floor is all yours, judges.
Yes, I might have a question. Yeah, indeed, great work. I enjoyed really the pitch and also reading through the documents, but yeah, I have one urgent question because I see a lot of people who might benefit from this solution, but who is the key user who experienced a problem here? That's not clear to me.
And sorry, I didn't say we have Diego Pereiro, Caroline Cusack, Oleg, I think you might be with us as well. So either three of you who wish to take the floor to respond to Dimitri, please.
Hi, hello. Sorry, I clicked to become a panelist, and it was rejoining the meeting, so I lost the question. Sorry, could you repeat me, please?
Yes, no problem. So my question was, you have a lot of stakeholders, and I see a lot of people are affected by this issue and could benefit of the solution. But for innovation, you also need like your key user or your key stakeholder who is experiencing a problem. In your case, who do you see as the key user of your solution?
I think a key user for our solution would be any people working in sectors like aquaculture or farming. We know that the sudden raising of seawater temperature can have devastating effects on the fish. So I think it's interesting for them to know which areas have a stronger impact of this type of events in the ocean, so that which areas are more sensitive, where is it better to relocate farms, what type of when measures can be taken when an ocean a marine heat wave is predicted. So I would point to that as the key users for this solution.
Okay, okay, that's clear. And then my second question would be then about the roadmap, because also now the roadmap, it it was for me a little bit high level also because I didn't really see who is your key user. But now that we identified this key user, how would you continue your development? What are the actions that you will undertake to involve this key user, and what is the stuff that you will do to ensure adoption of your solution?
Yeah, so the next steps would be not only to include the marine heatwave predictions, but also including information on the existing farms around the European seas that are interested in this idea. So for this publication of the project in which we are working would be needed. For instance, we are working this idea in a project funded by the H2020 with this ERC. So we are already in touch with stakeholders that know about this first developments. And yeah, so, and then we will need also to give access to this tool through the internet, so that end users could access it. So I think that those would be the next steps in our roadmap.
And in terms of time, because you say short term, long term, can you be a little bit more precise in that one?
I think 1 year could be enough to develop the idea.
Caroline, you're muted if you are talking.
Sorry, we have a deliverable due this summer, and it's we're involved with multiple stakeholders. Sorry, Diego, for interrupting you there. So we're working with environmental agencies, we're working with marine spatial planning people, and we're working with the aquaculture industry. And in a first instance, we're working with a fish farm, and we're deploying a buoy this month at a site so we can integrate that with the information. We're also working with benthic ecologists, and so the next step in the work will be to start to integrate the data from the marine heatwave spatial plans or spatial maps and the specific points to connect it with data sets from the different areas. And so ideally, you would actually upload that data that we would have into the Blue-Cloud, and also make the tool available to other people in the Blue-Cloud who can actually use it for their own biological data sets to see if they can make use and find it valuable. I think that would be quite important. Sorry, Diego, that's me done.
Thanks a lot.
Yeah, thanks for your answers.
So thank you very much, Diego and Caroline, and really the whole team for the great work that you've put forward in the hackathon, but also all the great that you're undertaking through the EuroSea project. All right, so we're going to move to the next theme now, the Perches. I see that we have the whole team marked as
last time you
speakers.
saw a beautiful, here we go, white bleached coral. Probably it was pretty recent, because our world is going to waste, slowly but surely. High temperature, as well as high levels of nutrients, pollution, and ocean acidification have caused mass bleaching events across the globe over the last decades. The question is, what can we do about it? We say, not much, but let's save what there is left to save. Coral restoration programs allow us to preserve the so-called hotspots. Once we then figured out how to live properly on this planet, they will allow us to bring back the marine life diversity the sea deserves. But how do you spot these hotspots? Current approaches only focus on the temperature, but remember all those other environmental factors I mentioned before? Well, welcome to PERCH, our tool for predicting the environmental risks in coral habitats. Using a gradient boosted tree regression approach, we forecast reliably future bleaching events based on much more than just temperature. With our tool, we want to inform researchers and marine restoration programs in the Coral Triangle on where to be when, just in time to save the world. But for the future, we want to extend the reach of PERCH and deploy our predictions globally, especially where they are needed the most. With PERCH, we want to purge the uncertainty around coral bleaching now.
Thank you very much. So I'm not sure who will be specifically responding to questions from judges. I presume someone from the team will step up. So the floor is open to our jury.
Hi, yeah, well, I had A couple of questions when we're ready.
Please go ahead, Dave.
Okay.
Thank you. Whenever you wish.
Well, thank you, the Perches, for a really interesting and very well presented piece of work. You note that perhaps the bulk of, let's say, approaches in the past relied primarily upon temperature as a sort of a predictor of coral bleaching. And you're proposing a new approach here, as I understand it, based upon machine learning, a black box approach in effect. How will you know that the approach you're proposing, that you're taking here, is better than what we currently have?
I think I'll go first. So that is a very just concern, I would say. However, we want to look on all the more factors than just temperature, and then basically quantify the impact of each variable, and possibly, given more time, also allow for a more explainable AI approach, extending the model that we have envisioned so far. So that would be also on our roadmap.
Bearing in mind that you anticipate, for example, coastal protection authorities using such a tool, and that is based upon, in essence, a black box approach, how would you determine uncertainty in any predictions that you would make from your tool? And how would you communicate those to an end user?
I mean, as you've probably also seen from our presentations that we provided to the judging panel, we weren't set yet on the boosted tree regression model. We were also thinking of a more Bayesian approach. Obviously, there the uncertainty quantification, is still not quite explainable. However, that would be something that we would have to investigate together with the stakeholders to provide something not only accurate, but also understandable from the parties that will act upon the information given the most. Also, we envision this less of a black box, here is the answer thing, but more of a decision support system that will take also into consideration the endeavors of the restoration or marine researchers.
And one final question. Would this tool be usable by non-experts, or is it only a tool that could be used by, let's say, data scientists?
So following the already available AtlantECO Atlas, we would like to build something very similar that is very intuitive to use, also for the general and wider public, because we think this is also the goal of the Blue-Cloud, to make data available not only to researchers, but to have the greater public as a stakeholder in the future of the oceans. And that is also our plan for this tool.
Okay, great. Thank you very much. That's all from me.
Thank you, Ricardo and Tim. So we'll move with the next video pitch. Michele.
Everyone likes playing, not only the dolphins, also data scientists and probably marine scientists as well. Therefore, we invented DataDolphin, which is a data analysis and prediction toolkit for marine scientists and ocean enthusiasts. It consists of 3 parts: a data analysis tool that reveals the general connection between the data points, a prediction tool that makes future prediction, a playground where people can be familiar with marine data. This is a brand new idea made for this Blue-Cloud Hackathon. We are new to marine science, but we are experienced in data science. During the hackathon, we made a dataset which contains data about island regions. Our goal is to build an online tool for all personas. We use data from the Mediterranean Sea. However, in the future, we want to integrate new data, for example, concentration of heavy metals, or data about living creatures. We built and deployed 2 deep learning models that run in JavaScript. Currently, this is a working proof of concept. We have a development roadmap for the next few months and a business model. This project is sustainable with paid services and free content, where we accept donations as well. Please support us. Thank you.
Thank you very much, Axel and Richard from DataDolphin team. You all heard the accept donations. So before that, the floor is open to our judges.
Hi, I'm Sylvia, and I have a question for the DataDolphin team. But first, of course, thank you very much for your proposal and the nice presentation and the enthusiasm. What I wanted to ask you is if you can explain when in your roadmap and in which way, or for you, which is the best way to involve the thematic expert and the scientific community, according, as I said, to your roadmap and business plan.
Thank you for the question. This is a very good question, and I have a very short answer to it as soon as possible, because our goal is mainly to serve these people, and therefore we are thinking it's really important that we can turn or we can pivot our development to direction which is the most convenient for them.
Okay, thank you.
Thank you, Sylvia. I'm not sure we might have another question from another judge.
Yes, I have also a question for the DataDolphin team. So I've noticed that you've mentioned a playground part of your one playground part, and I was wondering what will this playground part add to the student community? Would it be just to tweak with the model or just insert data and rerun it, or it would be just training for the students, or would it be for the professional to tweak the model?
Mm-hmm. Thank you. This is also a very good question, because the meaning of the playground has the word playground has 2 meanings in our project. One is that you mentioned, it's for data scientists and for scientists in general that can play with very simple tools to visualize the data, to find any interesting patterns or correlation or other things. And we have some basic model bases, just like, for example, AWS, the Amazon service does. But those models are specialized for these data points and the characteristics of the data sets that we know and we will use. And therefore, we are planning a playground where, for example, if you make a raw data search, then with the raw data, you at the same time can receive our toolkit, and you can make basic experiments with the data, and you can decide whether to continue this direction or that direction, leave the data or make a new search and so on. So our goal is to shorten the time when you decide about using that data or changing something in your search. And on the other hand, the playground means by us that we want to offer services for the public, for those who are maybe not at all scientists, or they don't really interested about the data itself, but they are somehow interested about the world of water, the world of sea, or the world of oceans. And for those, we are offering simple games, let's say, or simple visualizations. But the common property of those, the common attribute of those games or visualizations is that they have very strong data science background. And therefore, we are thinking this is interesting because it's not an all-day opportunity to play with something which is based on very hard data science approach.
Well, thank you very much, Othman. Does that satisfy your question, or?
Yeah, it satisfies my questions.
Thank you very much. Thank you, Axel and Richard, for your, or Axel especially, for your elaborate responses. And both of you for your great work. And
Thank you. Thank you for the opportunity.
Sure. We'll move forward to the next video pitch now. Please, Michele.
United Nations Sustainable Development Goals and many EU initiatives such as Mission Starfish and Farm to Fork and Blue Economy strategies call for rapid increase in aquaculture production. But uncertainties related to effects of climate change might impede investment. Food is 50% of operating costs. In 30 years, will farmers need more of it? How fast will the fish grow? Are diseases going to be a problem?
So, you'd like to know what the future holds. Here in Croatia, we expect less food per fish brought to market and a faster growth. Disease will be a nuisance, but probably not a major problem. Here in Africa, however, we expect the disease to pick up substantially.
The forecast you just saw from our Jupyter notebook was developed for the Blue-Cloud during hackathon ideation. We used open data sources to drive two models: the dynamic energy budget model estimating food requirements and fish growth, and logistic vibrio bacterial growth model to estimate disease risks. Our project Perfect may not be yet perfect, but can already help you plan investment, policies, and farming. The code is open. Please add features or let us know what you'd like to see. Check it out. It's already floating in the Blue-Cloud. All you need to do is click the location, choose the species, set the scenario, and click the blue button.
Thank you very much, Ines and team. Very impressive. The floor is open to our judges now.
Yes, I have a question.
Go ahead, Elisa.
Actually, there are two. So the first is you are referring your model will cover a grid that is 10 kilometers as grid size. Do you think this is perfect for the aquaculture sector, or do you think maybe you have to refine the grid a little bit more?
So as we stated in our presentation, this is what we managed to do during the hackathon. Mm-hmm. There was a lot of farming of the data, and we just didn't have time to go to a lower grid. Obviously, 10 kilometers is too large for aquaculture, but the principles are the same. We can bring it down to as high of a resolution as is available on the data sources, which we use Copernicus for now, but any other local data source or future data source that might appear will be just as good and can be easily implemented into the notebook.
Yeah, perfect. And another question is, it's really very nice to see that you have thought about integrating the DAP, the dynamic energy budget model. It's a very wonderful tool. And then you also for the growth, and then a growth market and so on. And then you have also the model that implement that the Vibrio occurrence in a way. How these two models, or how you think to integrate the information that are coming from these two models, or you're thinking to keep them separated as two products coming out from your tool?
Great question. So hopefully we could integrate that into forming kind of a uniform or like an overall estimate of feasibility. Mm-hmm. But actually, if you look at the deeper meaning of these indices we've used, we have costs and benefits in there. So time to market is actually an index that tells you how quickly you expect your fish to be done. It helps you set up infrastructure requirements, etc. Food conversion ratio lets you know how much money you will be able to make per fish. And Vibrio, the index we introduced for vibriosis, kind of tells you what your risks are. So that's kind of a cost part of the scale. So even though it would make sense to integrate them into maybe for policy making, actually, not for perhaps for individual aquaculture farmers, but for policymakers, it makes sense maybe to integrate those into an overall index of feasibility or something like that. But I think for individual aquaculture farmers and maybe even the public, the 3 separate measures will be a more informative metric than just putting it all into one single number.
No, I agree with you. Not one single number. Integration of information. In fact, I was not thinking about information of integration of the data. But for example, would be also interesting if you are able to do a temporal scale of your simulation. If the Vibrio is entering the system, you could farm your fish before, so you can slaughter your fish before the end of time. You will earn less, but you will not trash the whole production. So this could be a parameter that could be interesting to.
No, that's definitely a great idea, but I think we would need a bit more development on the probiosis model because as it is right now, I think it's quite robust in basically measuring risk in terms of days that are critical. So when the Vibrio could be above a certain threshold, but to make a decision to kind of shorten your farming cycle and take the fish out, that's a very expensive decision if you're making it at a wrong time. I would actually advise a bit more research on that and in situ measurements, at least of temperature, that it could be fed into a Jupyter notebook that could kind of interpret those data. But that's actually not implemented now, just to make it clear. It's a very interesting future outlook.
Thank you.
Thank you.
Thank you very much. Do we have another question from the judges?
Yeah, I have a more general question, I would say. How do you imagine your final output to also, I mean, in terms of really, is an app, is something that you want to integrate into a tool, etc. So basically also the most important part is how do you want to reach your stakeholder, the way in which you want to do?
Great question, and it has, I'm sorry, but it has multiple answers there. So right now, I think it could be useful to particular farmers and maybe even policymakers to kind of pick and choose locations and see what's going to happen. But if integrated with, for example, aquaculture, I mean, and you must know, like aquacultures track how much food they put into their farming operation, and they have software tracking fish growth, etc. And if we integrated that information with the predictions, then we could actually give additional value to particular farmers that, to me, would make most sense to be applicable either as a thin client on a desktop or maybe a standalone app that would draw data from the Blue-Cloud and then present the results to the user. Now, what I see as a strength of what we've done so far, and please keep in mind this was a week's worth of development, although I would like to really commend my team or our team, the coders on that. I think the best feature is that it's open, it's on the Blue-Cloud, and anybody can do whatever they want with it. Of course, we're here to help. If we have, and we've shown that in presentations, we have ideas of how to expand this. And we were actually hoping that being on the Blue-Cloud could also add to the visibility of our product and our efforts. In fact, we plan to leave this on the Blue-Cloud and advertise it as such to potential users in Croatia and hopefully elsewhere. I don't know if that answers your question, but
we can stay forever if you want. But it's okay.
This sounds ridiculous, but it's an important point because I've seen so many projects have something cool up, and then just disappear after 5 years when their fees they pay for the servers run out. But this, you know, if the Blue-Cloud infrastructure stays here and is supported by the European Union, I think that could be a great asset to all of us that don't really have the financial clout to keep up these types of projects running. And it's really unfortunate, I think, that many good ideas have fallen through because they weren't available anymore. And Blue-Cloud could fix that. And I'm looking forward to it.
Thank you very much.
Thank you.
Thank you very much, AqADAPT team. And it's great to see that you're all in the same room. Wonderful.
Yeah.
Hello to all of you. Okay, we're going to move to the next video pitch now. Michele, please.
All right. The next team is aquamap.
Did you know that 50% of fish for human consumption comes from aquaculture?
However, the ocean belongs to us all, and marine spatial planning has to balance competing demands on the maritime space.
This is where the Blue-Cloud and we, Team AquaMap, come in.
We started to develop and implement a framework for creating maps that indicate the suitability of sites for aquaculture. This works by integrating diverse data sources from the Blue-Cloud and elsewhere. Multiple factors are considered together to arrive at an overall aquaculture suitability score for each location.
We created an open access tool in the Blue-Cloud platform that allows interactive exploration of factors relevant for aquaculture. So let's see how it works.
Here we show interactive tool where we can switch on layers for different variables and create suitability maps dynamically. This allows marine spatial planner to arrive at a comprehensive overview of the potential for aquaculture in a region.
Also, it can act as a communication tool to interactively discuss marine spatial planning with communities, stakeholders, and farmers in a workshop setting.
Thank you very much and welcome Team AquaMap, Peter and colleagues. The floor is open to our judges for questions.
Yeah, I think it's still me it's really very, thank you so much for the pitch and all your work is definitely something that is very needed in the aquaculture research and the production sector. First, it's not really very clear how you want to put together all those information. So how you will integrate this information is through weight system, through a score system, through color system. So this is the first type of the question. The second is, I'm sure when you started this, you had this idea for the pitch, you looked quickly how this has been developed before, because as I say, this is not a topic. And there has been many projects working already on that and tools available and also online for exactly with this scope. What is the added value of what you are proposing of this in this nice pitch?
Yeah, thanks a lot for the question. So to the first point, so basically it's a multi-criteria approach where you are interested in evaluating suitability based on multiple criteria. And there are many different ways of how we could aggregate these different criteria into an overall score. And at the moment, we just implemented a very easy solution based on thresholds and sort of a minimum aggregation. So it's kind of one factor out, all is out, because that was the easiest to implement in the little time we had. But we are looking forward to sort of making this a bit more detailed, allowing more fine-grained control over how to define this overall score. So there's the opportunity for weighting, for other types of aggregation functions. I think there's a lot of possibilities that we could implement programmatically there. The second question was, so what new things can we offer? What's really a new thing. So I think the one thing would be actually that Blue-Cloud would be part of this new offering, because as was also mentioned before, there's a lot of software projects that come up, and after funding ends, they die. And so that I think it would be, what we could bring is to bring a service that is more longer lived. And in terms of complexity of what we can offer, I think we can, if with given a bit more time, we can sort of offer the state of the art that other tools also can offer. That would be my answer.
Thank you.
So I had a question also. What would you regard as the greatest source of uncertainty in any output to your analysis? And so how would you reduce it if indeed it was necessary?
So I think there's two big sources of uncertainty. One is sort of in the data, I mean, that we get, and the other is in the evaluation, or sort of how, let's take the example of a weighting. I mean, what does suitability mean, and also perhaps mean for different types of stakeholders? There's a lot of uncertainty in that regard of how you would combine the different factors. As to how we can reduce it, I think maybe a better way would be to live with it and make it explicit, instead of trying to, because it will be there. I think we will have to cope with it, and so I think it would be nice to be able to visualize it or make it explicit what the uncertainty is.
Okay, thank you very much.
Thank you very much, Peter, Fridolin, Debbie, Daniel. We are going to move forward to the next team now. Thank you, guys.
Very good. Next team is TeamCoral.
Welcome to TeamCoral. We aim to create an Impact Atlas Mediterranean aquacultural farming interactive map. Agricultural farms could result in eutrophication and further lead to harmful algal blooms and oxygen deprivation of marine life. In our solution, Jupyter Notebook was used with libraries such as Pandas and Folium to create an interactive map using circle markers to illustrate the location of the farm. For the clusters, a difference map was created using data accessed through Blue-Cloud to generate a map demonstrating the difference of before and after a certain agricultural farm was built. A pop-up function was also added to show further information. This included suggested solutions such as fish oil solutions, smarter and more green floating cages, deep water farming, and sugar kelp. We intend to find data such as the year and time these farms were built and demonstrate further difference of nitrogen before and after the farm was built. This can be used for further projection and monitoring to potential hazards introduced by agricultural farming.
Thank you very much, and we welcome Marian and Tim, and the floor is open for questions.
I have a question for TeamCoral. For start, thank you for the great work. I think the presentation was really clear and the idea smart and achievable. I have a question on the use of Blue-Cloud services that you did. Can you elaborate how you used the Blue-Cloud services? In particular, how you use the data access and discovery service, so data.bluecloud.org, to create this atlas of impact hazard. What was the workflow you used?
Hi, thank you for this question. Indeed, this project, we have utilized the data from Data for Science, the platform. It's actually a very nice platform. It's very clear design, and we just search for the variable that we're interested in, and it will lead us to the actual data provider, and it also provides really easy both pullover and downloading service is quick and easy. So, and this is in terms of here we are using a nitrogen as example. So the nitrogen data we utilize here is obtained from Data for Science, Blue Science Data for Science platform. Actually, the current data we're looking at, the farm location dataset, we obtained from another source. Our team leader, would you like to comment regarding for the other source? Okay, so basically we get the other data from another source mainly because we start to prepare this a long time ago, and we wasn't able to access the data provided by our platform because we thought it will only be available after the hackathon started, but it turned out it's just the link was kind of invalid. But I think they are both very nice data source.
Thank you.
Yes.
Thank you. Might we have another question?
Yeah, but my question was related, yes, indeed, with the data source, because also in your presentation you say that due to the lack of data in the building year time, so I was wondering if you have considered or thought about alternative data sources for your temporal analysis.
We would like if we can find a data source that also provides when the farm, the aquaculture farm is actually built, it will be much better. But for also our mentor has also helped us with this information. He said, indeed, unfortunately, the current data source we have in our hands doesn't include this information, but we believe this idea, it works for us to take more effort searching this data set, and if possible, we can even complete to kind of improve this data set by providing the farm building time by ourselves, which I think it will be both a benefit for our project and also for future other researchers or just the data they are providing. We do hope that we can find, but within the short time of searching, we haven't found one yet. And please let us know if you do know this resource.
Okay, thank you.
Thank you very much, Ishin, Amina, TeamCoral, awesome work. And we're gonna move forward to the next team now. Thank you very much.
Our next team is Marine Wildlife Fathers.
So welcome, Brian and Tim. And once again, the floor is open for questions from our judges.
Yep, I have a question or two. A great presentation and a great PowerPoint and really exciting visualizations. So your contention really is that marine protected areas don't work. Explain, why is that?
Hi, David. So I hope you are listening clearly right now. Well, the assumption about the marine protected areas are not working is because the discoveries about the movement of wildlife has been showing that the meaningful spots of them are not always not always inside the marine protected areas. And actually, this has been demonstrated already with some tests that has been done with cetaceans, and they show that they move in the marine protected areas, but this is not enough. They have a lot of risks, specifically for fishing pressure, and their meaningful spot about phytoplankton for foraging, they are not always inside. So we would like to assess this process and support the improvement of this delimitation.
Okay, thanks. And so you show on your presentations a link between, let's say, phytoplankton, biomass, or proxy for it, chlorophyll, and the movement of marine mammals. What do you see as the link between phytoplankton and large marine mammals?
The link is actually based on their migration. So when I was reviewing the datasets of phytoplankton from Blue-Cloud, I noticed that there is a tendency that at summer, the concentration goes to the north, specifically to the Arctic, as you see in the video. And then in the other part of the year, they go down. So actually, this is the same dynamic that the marine mammals are having in migration. They migrate to the north, where the high concentration of phytoplankton is. And when they are in the other part of the world, they are also in the high concentration of phytoplankton. So this dynamic actually was easy to see with this platform, and I believe that this is a very good insight for marine scientists.
Okay. And so who do you envisage as the main users of your application?
So the main users were focused to work with marine scientists and marine spatial planners, especially for those that are specifically involved in marine wildlife protection and marine protected areas assessment. Okay. So quite narrow. Thanks,
okay,
David.
Thank you very much. That's really interesting. Thanks.
Thank you very much. Might there be another question?
I have a bit technical questions, if I may. So could you elaborate how Blue-Cloud service you used in your solution, in your proof of concept? And suppose that you need to evolve this proof of concept, what geographic GIS resources and technology use to the proof of concept to a more mature prototype?
All right, so the services that we have been using has been the data products from Phytoplankton Virtual Lab. They were very specific about giving the dataset. So what I did is just include this dataset in the backend and make them work. And for the second questions about the GIS resources, so the platform is already developed with Kepler GL. That is a platform for uses of geospatial big data set in a graphic service. So what we would like in future is to include a more powerful cloud service that can help to invite more marine scientists to include their data set in the platform so they can keep following. So just to be specific, we want to focus on Kepler GL as a visualization framework and Streamlit as a cloud service.
Okay, thank you.
Thank you, Massimiliano.
Thank you very much and great work, you guys. Okay, we have to move forward. We still have two more teams, I believe, Michele. So we'll move to the next.
Exactly.
Please go ahead.
Next one is AtlantECO.
Our project aims to use observation data and select machine learning algorithms to extrapolate variables in space and time, also known as mapping. We actually have too much data now. It has become very hard to separate the rubbish from the actual meaningful information. So we as a team wanted to tackle this important issue during this hackathon. We developed a new and user-friendly data mapping tool that we'll call the Mapper. It could be used by scientists within the Blue-Cloud or in other research projects, but also policymakers, ecosystem managers, or even a larger public like young academics that want to study marine biodiversity and share it with their friends. So Nelia, how does this work?
Well, so we built a pipeline where the user can input their own observational data or use data from the Blue-Cloud. We then match this user input data with environmental data from the Blue-Cloud, and we perform all the pre-processing that is necessary. Then we identify the most important environmental predictors that define how much or where the target variable occurs. We use these important predictors to do an ensemble of machine learning models, and ultimately will provide the user with both global predictions of their target variable and uncertainty assessment that highlights data gaps that still need to be filled, and directions for future work as to how to proceed with the modeling.
Yeah, let's talk about the future, Nelia. So in March, we will explore further collaboration between the Blue-Cloud and a research project called AtlantECO. And we hope that in the next few months, we will improve our mapping tool to make it even more complete and easy to use.
All right, so welcome, Mieke and team. The floor is now open for questions.
I have a question if no one else wishes to step in. You note that ocean plankton observations are increasing exponentially. Can you give me a clue as to where these observations are being made?
Well, I mean, in the past decade, the ocean observations have increased exponentially, not only because of the increasing amount of cruise activities and measurement campaigns, but also because of the use of multiple data streams on the same cruises that combine traditional observations with imaging analysis and also omics measurements, which leads to a multitude of measurements for the same measurement or sampling station.
Okay, thanks. Thank you for that answer.
I have a more general question. I mean, the scientific part is good, but how can we explain it to a less, well, youth, maybe people that don't understand much the scientific part? Do you feel that the models and your programs and everything could be explained to people that do not have an understanding to the mathematical or optimization tools? Could you think this is possible?
Yes, in fact, I explained what we are aiming to do, or what we are going to do to my 7-year-old daughter last night. And I think pretty much everyone knows the concept of distributional habitat maps from a visit to the museum, for instance, where you can see where a bird lives, or a visit to the zoo, where the range of a certain species or OTU or other taxon is indicated. And I think this is really a point where you can connect the terrestrial experience with the marine one by creating such maps also for marine organisms.
Thank you. Perfect.
Thank you very much, Team AtlantECO. I believe there are no further questions for you at this moment. So we're going to move to the last video pitch of today.
The Chlorophyll Sandbox is an analytical framework dedicated to the study of the chlorophyll A patterns. It leverages the scalability of an Elasticsearch cluster and enables a readily accessible digital twin ocean, fit for machine learning on big data. 20 years of satellite data at the global scale, more than 25 billion measurements, are available to deliver insights for any region of interest. The Chlorophyll Sandbox has a particular focus on analyzing the spatiotemporal patterns of the chlorophyll A fronts. If you are an environmental scientist, an MPA manager, or a policymaker with interest in marine conservation, climate change, fisheries or aquaculture, you have access to key knowledge without any technical expertise. All your analyses will be delivered in reports in near real time, which you can upload and share. If you are an advanced user, the Blue-Cloud Virtual Lab offers you the possibility of exploring the Chlorophyll Sandbox's functionalities to create your own analytical flows. During the hackathon, we developed the pilot technical infrastructure, the gradient datasets, the Elasticsearch cluster, the coding of an ETL batch, ingestion of data in the cluster, and coding of the notebook. After the hackathon, we will have to code a tool for exporting the analysis reports to the Knowledge Hub, publish the sandbox as our package, and launch a crowdfunding campaign.
All right, so welcome Pascal and Tim, marine analyst. The floor is open for questions.
Yes, if I may step in, very nice. I'm also a bit triggered by the digital twin reference, as IMEC, we're also working on digital twins, but you are also talking about lay users. Did you involve them at some point? If I understand it correctly, you really have some very easy outputs for people who are not that technical. How did you involve them, or how do you plan to involve these kind of users in later stages for the further development?
Okay, I start. Hi to everybody. So Laurent is also connected. Let's say that Laurent is the typical end user. He is working on fisheries concerns, and we interact very often about his work, his daily work. Or we can have, let's say, mobilize data to answer difficult questions, and also, yeah, I've been involved in many stakeholders. It's always the same issue: mobilizing data and providing solutions. So what we like very much in the Blue-Cloud initiative, it's the collaborative platform. Capacity building. So when we started to discuss about the project, we said yes, notebooks, open science, open notebooks. It's very nice solution to provide access to the end users, so that we can demonstrate at different level, the advanced user and the simple user, what can be offered as solutions.
The typical layman is me. I'm a linguist, and I'm not very scientific, and I'm testing all the layout and all the functionalities. So I can more or less say, well, hey, I don't understand this. So can you make it easier? But yeah, that's.
Oh, I see that Laurent is there, so he might also.
I can add something. It's as a marine scientist or a fishery ecologist right now. My main question was when I need to work on an area, what has data available to work on this? And what we did during this project is to try to answer this question.
And maybe in terms of then the roadmap, because how would you then further develop it? What would be the next steps, and what is the timeline to really end up with some functionalities that you want to finish? Can you be a bit more specific, because it's now a bit high level?
Well, it's not that much. The straightforward answer is to integrate the service into the marine analyst, which exists already. And other possibilities are open as well. It could be integrated in one of the Blue-Cloud services, or for another organization. It depends what opportunities arise.
What is very important and what is key is the dissemination, the outreach activity, to really build a community, so that this community. We spoke about crowdfunding, but also crowdsourcing is a very important activity that we foresee. So to have as many users at different levels, different technical level involved in the project. So it's really about opening the solutions, opening the access with let's say a community-based communication and participation.
Right, thank you.
Thank you very much. Not sure if there might be one last question from the judges.
Yeah, I would have a question if no one else wishes to.
Please, Dave, go ahead.
Yeah, I'd be interested in knowing how you define a front, and also are there other features that you could let's say, identify from the data that you're gathering that are ecologically significant?
Well, maybe Laurent can answer part of the question. I will answer the second part. So please start, Laurent, on this.
as it is a front is just a gradient, a spatial gradient as we define it in our algorithm. Very different definition in the literature. And what we used is one, I don't have the paper in my head, but it's a classical one. So it's a gradient. It's a spatial difference of the phytoplankton differences. Then go ahead, Pascal.
About the other data sets that we can integrate. What was really interesting in this project, this pilot, is to integrate different type of data, structured data and unstructured data, because we are now at, we see that with machine learning techniques, we can discover a lot more information. And what is nice to do is to see how we can mix structured, unstructured data. So I'm going to say, for instance, here, we've got a use case with satellite images. But let's take, for instance, if I would like to add to my use case human activities. It's a different type of data. And I would like to put all this together in a machine learning technique, deep learning technique, and to understand what are the insights that I can produce. And for this, you need to have the big data technology. So I've been very inspired by what Google is doing, actually. When you see a search page of Google, you just have few words and you start to have an answer. And I wanted to do the same thing with data, real world data, but not only satellite images, but also some other type of data, like, I don't know, vessel traffic or human activities within MPA, marine protected area, and so on. So really to be open to find a solution to integrate and process, and this is very important, this aspect of federated machine learning, to have the right technology so that you access, you mobilize the data. And what is important is to do it in a distributed way. But now it's technical. So, but that was the idea of the pilot.
Thank you, Pascal. Thanks for the team.
Well, thank you, Pascal, Claudia, Laurent. Thank you for that. Well, here we go. These are the 10 finalist teams of the Blue-Cloud Hackathon. Thank you, everyone, for being here to respond to the questions that have been presented by the judges. We are now going to let the judges off the hook so that they can decide which ones of these 10 teams become the winners of the hackathon. Michele and I are going to join them in their meeting. So we're going to be leaving you in the capable hands of our colleagues, Nathalie Tonnet and Federico Drago. But remember that while we are away, we're going to be opening a poll so that you two can vote for your favorite team. So stick around for that. And we will see you. We're running a little bit behind schedule, but it's fine because I think this Q&A session has been very insightful. So we will see you here, I would say, let's say 5:45 as originally planned, but be aware that we might be a little bit late, 5-10 minutes tops. But I would say that we will resume the webinar not later than 5:50. So please make sure that you take this opportunity to vote for your favorite team. You can watch all the video pitches of all the 23 teams that have completed the challenge, and you can then vote for your favorite team. We'll be right back. We'll see you in a short while. Thank you very much, and we'll see you soon. So we're back. I hope that everyone can listen to me well. Thank you very much for your patience. Sorry that it has taken us a little bit longer to get back to you. I bear witness that you have made things very, very difficult for our judges. So before I give the floor to them to announce the winners of the Blue-Cloud Hackathon, Michele, I believe you have a couple of announcements to make.
Yes, exactly. Thank you very much, Julia. All right. So first of all, I would like to thank all of you that posted some link to the songs of the playlist that we created. You can look for it on Spotify, and we hope that it can inspire your work. Maybe keeping working on the Blue-Cloud with this playlist. I've seen a lot of participation from the mentors, from you, from the teams. It was great. I think that we have 3 hours and a half of music, so I think it's pretty much enough. So you can look at it. And then here we also, during the hackathon, we run a couple of mini challenges. The first one was the selfie challenge. And of course, the winner was Claudio Pierar. And I mean, with a selfie like that, working on my deadlines, doing the Blue Hackathon instead, it was great. I mean, you could not win. I mean, this must win, so right? So this was the winner of the mini challenge number 1. And then we have launched a second one, which is I always. So when participating in the Blue-Cloud, I always, and then you needed to put your phrase there. And in this case, the winner was Rahul Deep Singh, and he wrote, when participating in the Blue-Cloud Hackathon, I always co-create workable solutions and share the load for the purpose of achieving sustainable healthy ocean. So thank you very much, Rahul Deep, for this Twitter. They're really, really meaningful. Thank you very much. All right, so it's the big moment, right, Julia?
Thank you, Michele. Yes, I hope you can hear me better now. I had a bit of a sound glitch. So yes, as I said before, you made it really difficult for our judges. However, they've reached their verdict, and you have as well. So I hear we also have a clear winner for the Blue Skies Award, which is the lucky team who will be able to send 2 participants to the final conference of the Blue-Cloud project, hopefully in Brussels, but we'll have to cross our fingers and wait a little more to find out about the final location of that conference. So I'm going to invite my colleague, Nathalie Tonnet, who's been great help for the hackathon, to announce the winner of the Blue-Cloud Blue Skies Award based on the popular vote. Nathalie, over to you.
And the winner is the particle trackers with the idea See Clearly. So the overall aim of their idea is to provide the locations and conditions for safer pollutant-free fish to be farmed in aquaculture cages.
Right.
Congratulations.
So congratulations, the particle trackers, winners of the popular vote, and we can see the results of that voting session in our screens at the moment. So congrats. Let's move forward now. I'm going to invite Dimitris Schurman, member of the jury, to announce the winners of the 3rd prize.
Yes,
Dimitri.
for the 3rd prize, we have chosen a wild card. So competition was very close, but from the wild cards, we found one project very interesting, also a little bit out of the box. And that project that we found, that was the 3rd place, was the Marine Wildlife Trackers. So very much congratulations with your prize, and I hope that we can see much more out of your project. Congratulations.
That's awesome. Thank you very much, Dimitri, and congrats to the team. I wish we had music to go with the background, but I'm sure it's playing in your heads as well, so hopefully that's fine. So congrats, and I'm going to now invite Elisa Ravagnan to announce the winner of the 2nd prize.
Yeah. So it has been really very difficult for us to choose. Very nice work, everybody. Congratulations to all. But as a 2nd prize, 2nd position, we have the AqADAPT team with the perfect tool, and so the performance of the aquaculture under climate change. Congratulations.
Awesome. Congrats, Team AqADAPT, indeed for a great work. All right. So finally, Dave Mills. I'm going to invite Dave, who's also a member of the Blue-Cloud External Stakeholder and Expert Board, to join us to announce the winner of the 1st prize of the Blue-Cloud Hackathon. Over to you, Dave.
Well, good afternoon, everybody. An exciting opportunity for me to present the outcome of what was really been an enjoyable event to participate in, really exciting. And I feel that the challenges, the scope of the challenges that have been addressed really are so pertinent to the challenges that we face going forward. And I'm really pleased to announce the winner of the hackathon is the particle trackers, and with the idea see clearly. Really, amongst many excellent ideas brought forward, this stood out for us as something which addressed really two major challenges. How do we feed the world? And the real incredible problem that we face in terms of plastics. So not only are you tackling really socially critical challenges, really wicked problems, but also coming forward with a solution which really engaged us all in a view that this was the right approach for the right problem at the right time. So we are very happy to announce that you have won this hackathon. Thank you very much.
Thank you very much, Dave. Congratulations, the particle tracker. And we were wondering whether someone from your team might wish
Here we
to
have Delphine, Julia, yes.
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 Well, thank you so much. We're really touched. We have a group chat going, and we're all super excited about this. We wanted to thank the Blue-Cloud for this opportunity, and all the jury and our mentors. And yeah, we're a group of 8 early career ocean professionals. So this is really, an incredible experience for us, and we're really excited to bring this forward and to develop it further. So yes, thank you so much.
Thank you very much, Dolphin, and congratulations to everyone, really to all teams. Well, I guess this wraps it up. Thank you again to our judges for their amazing work, and congratulations to the winners. Thank you all really for your amazing participation. It's been great, a real honor to share this journey with you. Please know that we will be reaching out to the winners of the hackathon tomorrow to follow up with all of you on the next steps. But before we close and say goodbye, we have some final messages for you from my colleague, Connor Delaney, Technical Coordinator of the EMBOTnet Secretariat, and from Sarah Pitonet, whom you've met already, Coordinator of the Blue-Cloud project. So Connor, over to you.
Oh, hi, can you hear me?
Yes, we can.
Excellent.
Loud and clear.
I just want to very briefly thank the Blue-Cloud thank Blue-Cloud Hackathon for allowing EMBOTnet to be involved and share its resources, its technical data sharing resources, and test them out to see how well they work. I mean, this is one of the great things about hackathons, is that we can experiment with novel technologies and novel thinking. But of course, that's not possible unless you have fantastic participants. And I can see from the presentations there that there was a huge amount of participation in this project, which really is very touching and leaves me optimistic for future hackathons and future work in ocean research. But those participants, of course, were very much supported by the mentoring team and the advisors, and I would thank them as well. And I just want to also mention cheekily that in 2023, EMBOTnet will have the Ocean Sea Lab, which will be another hackathon, and we will be announcing all the details on that later on this year. So please keep an eye on the wires and see, and we'll keep in touch. Thank you very much.
Thank you very much, Connor, and everyone you've heard. If you still have energy left for another hackathon, well, there's another one coming up happily in a few months, so you have time to rest. Sarah, thank you for joining us today, and over to you. I'm going to ask Michele to please maybe move to the next slide.
Thank you, Julia, and really thank you, everybody. Thank you, all of you who took part in this hackathon. As I think I've already said, this is not the end. Actually, this is a new start for all of us. So I've heard of excellent ideas during these 2 days. I've heard comments stating that we want this to continue. So you're fundamental to allows us to continue to set the stone toward the sustainability and further, exploitation channels to all these resources that are available. So, again, it was amazing seeing so many teams involved, and the outcomes I'm sure, of this hackathon, I'm sure will stay. So again, thank you all, I mean, from the judges to the teams to the mentors. And I think we all concur, we all agree in sending a special thanks to Vera for managing all this machine extremely smoothly and with these excellent results. And with that, I hope again, this is just a start and we'll continue working together. We'll follow up with you in the next days with the winners, but also I'm sure we'll find a way to keep in touch also with the other teams.
Thank you very much, Sarah. Thank you. Michele, if you can please move to the next slide, just so we can say goodbye to all of our participants on behalf of the Blue-Cloud Consortium. It's been a pleasure having you on board, and we'll be in touch. Hopefully we'll see you around the Blue-Cloud, hopefully. Thank you.
Thank you, all of you.
Bye.
Thank you, bye.
Bye. Thank you.
Bye-bye.